Hey everyone, welcome to homework, end of unit 2. And so today we're going to start by getting ready for your next unit. Unit 3 is all about exponential functions, and so we're going to start with a review of exponents. So let's take a look at today's homework. So the first thing is that we are looking at our exponents in expanded form and in exponential form. So in the one column it's in expanded form, and in the other column it's in exponential form. So 3 multiplied by itself 4 times is 3 to the 4th power. 5 squared is 5 times 5. Now, generally, when you see this, you know how to do this, but when we have x's then, what happens? Well, again, it's the number of times we're multiplying it. So this is 1, 2, 3, 4, 5, 6, 7, x to the 7th power. And each of these invisible exponents is a 1. And so when we're multiplying exponents of the same base, we're simply adding the number for the exponent because that's the number of times that we are multiplying it by itself. So y to the 3rd power is y times y times y. Now in this case, x times y squared is interesting because this would essentially be x times y times x times y. Well, this can also be x squared times y squared. So as long as you are multiplying everything by the exponent, in this case outside of the parentheses, you are all set to go. All right, so in this example, Claire has a summer job. She wants to save money on the family vacation at the end of the summer. She is going to save $5 per week for each of the 10 weeks that she is working. Tyler also has a summer job and he would like to save money. He is going to start by saving $2 the first and second weeks, and then he's going to double the amount he saves the other weeks he is working. So we're going to complete the table to show how much. So she's saving $5 per week. So this is just going to go up by 5s. You're going to skip count by 5s as she earns more money each week, right? And it is 5x. She's earning $5 per week. Tyler, on the other hand, the first week he's doing 2, then and then the second week when he adds the $2 from the first week, he's going to get $4. Now, the third week, though, he's going to double the amount that he saves. So he is going to multiply that by 2, right? He's increasing that by 2. So instead of adding right here, we are adding 5 each time. Here we're going to be multiplying by 2 each time. So we'll get 16, 32, 64, 128, 256, and then 500, 612, 256 times 2, 512 times 2, 1024. And so here now we are not just multiplying by x. What's happening instead is initially we had 2, right? And then we have times x, but what is happening each time to the number as we go? We're multiplying it by itself. So in this case, our starting value was 2, but now every time we are leveling up by multiplying by itself. So it's 2 to the power of x, because if I do 2 to the power of 2, where x represents the weeks, I get 4. If I do 2 to the power of 3, that's 2 times 2 times 2, that gives me 8. If I do 2 times the power of 4, I'm multiplying it by 2 again. So because each time I'm multiplying the series before by 2, I'm going 2 to the power of x. All right, for our next part, it's asking you to match the expressions from this list with the expressions from B and C. So 8 times 8 times 8, another way to say that is 8 cubed, right? But notice none of these options have that. So what we need to do is then calculate 8 times 8 times 8, or 8 cubed, is 512. So which of these would also equal 512? Well, from list C, we have this one here. So that would be that. And then for my other ones here, I'm looking at what else would I get the same thing from. So here, this would be 2 times 2 times 2 is 8. And then 4 cubed is 4 times 4 times 4, which is 64. That doesn't look like a 64, but it is 64 times 8 gives us 512. So this is from list B, 2 cubed times 4 cubed. All right, so that's all you're doing for this one. I'm going to let you do that because you need the practice of doing this by yourself. But you're trying to figure out which of these match up with lists from list B and list C. I will give you one more example. If we were to look at the fractions one, let's do that one because that one's always, fractions can sometimes be tricky, right? This would be 1/16 times 1/2 is 132. So that's our answer from list C. But then we want to think about, well, how else? Well, obviously the only other one with fractions is 1/2 to the 5th power. And the reason that that works is because we're doing 1/2 times 1/2 times 1/2 times 1/2 times 1/2. And when we multiply 2 by itself 5 times, we will get 32. All right, you can also think of these as breaking down. 1/4 is 1/2 times 1/2, right? So this can be broken down into 1/2 times itself 4 times plus the final 1/2 that they have there, right? So these here are 1/2 times 1/2 4 times, and then times that final 1/2. All right, so you need to do this one, and the last one. You can use my other ones as an example. The second part of this is going over exponent rules. And so if you've forgotten these, we are going to review them, but you need to know them for this unit. So the product rule means when you're multiplying monomials, meaning you're multiplying these variables that have the same base, you add the exponents. So for example, x times x cubed times x to the 4th is the same as x all to the power of 1 plus 3 plus 4, which is x to the 8th power. And the reason is if we were to expand this and write x times x times x times x, that's 3 times another 4 times, we are multiplying x 8 times. And so that is why it is x to the 8th power, and that's why we can go ahead and add those bases, or add those exponents when the base is the same. So in example 2, it's showing you that we do need to multiply our numbers, right? So 2 times -3 is going to be -6. And then for our exponents that are the same, just draw a line to separate this, when our exponents are the same here, we can add these exponents. And so this becomes -6 times 2x to the 5th power, and then we can add the exponents of y's. Y, the invisible exponent here is 1, so this becomes y to the 5th power. That's the first rule. The second rule is when we're raising monomials to powers, multiply the exponents. So if it's to the power of and another exponent outside of the parentheses, that's when you would multiply your exponents. All right, so if you're multiplying variables, you're adding the exponents, but if you are raising an exponent to the next power, you multiply them. And then the quotient rule is the opposite of the product rule. So instead of adding, when we have monomials with the same base, instead of adding our exponents, we subtract the exponents to get our answer. So you can look at these 3 examples to get an idea of what that should look like. So for this part right here, the important thing to remember is that every number that doesn't have a visible exponent has an exponent of 1. So here this is a to the 1st power. 1 plus 2 plus 3, we're going to add them because the base is all the same, so this would be a to the 6th power. Here, I'm going to multiply 2 times 4, which is 8. I'm going to then combine my a's. A to the 2nd power times a to the 1st power is a to the 3rd power, because I'm adding the exponents because the base is the same. Same thing here, b to the 3rd power, because this invisible 1 is here. It is b raised to the first power. All right, continuing on here, 6 times negative 3 is negative 18, and then x has the same base, so x to the 7th power. All right, so you get the idea of that. Let's take a look at number 6. Number 6, now I'm raising everything to the 2nd power. This includes this first number here. So this is 2 squared, which is 4. X squared to the 2nd power is x to the 4th power, because 2 times 2. And then y cubed to raise to the 2nd power is y to the 6th power. Now I am multiplying my exponents because we are raising it to an additional power. 5 to the 3rd power is 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. X squared to the 3rd power is x to the 6th power. Y to the 4th power to raise to the 3rd power is y to the 12th power. All right, so you try 8, 9, and 10. In number 11, we are dividing. So this would be the same as x cubed minus 1, because the invisible power is here, so this is x squared. Here, 18 divided by 3 is negative 6 to the power of c. 3 minus 2 is 1, so you can just leave this as negative 6c. And then I'll show you one more. 9 divided by negative 3 is negative 3. A to the 2nd power, because 3 minus 1. And then b to the 3rd power, because 5 minus 2. So you try 14 and 15. Okay. 16 through 25 is kind of doing a mix of these. Here we have the same base, so we're simply going to add the exponents. Here we're raising a power to another power, so we're going to multiply our exponents. All right. Now this one is unique because we are not multiplying or raising, but these are like terms, so I can simply add these, and my base is going to stay the same here because I'm adding. When we are adding these, x to the 3rd and x to the 3rd, we're just adding our coefficients 2 and 7. This is going over another rule. Anything to the 0th power is going to be 1. And so it's just recognizing the 0 rule for that. All right, I want you to try the rest on your own. 25 is kind of, I'm going to say a bonus because it's a little bit tricky, but I want to see what you do with it on your own. Today's code word will be post-it, like a post-it note. Happy homeworking, and I'll see you tomorrow.